everybody. I'm Sajjad Ghazanfarinia. I'm going to talk about the AMAJ project, a multi-purpose constellation for kids. I'm representing the team. Uh, I'm founder of Fazl.ir, and a startup on space education and outreach. And we do have some projects on education and engineering and entrepreneurship. And as you can see, AMAJ is one of our orbital projects. In this project, I have three folks from Iran, Vahid, Amiran, and Reza in electronics, communication, and software. And also we have a great team from Argentina, uh, heading by Alejandro, as you may know him much better than me. Alejandro is the founder of Space from Argentina, and we do collaborate on this project with each other. Uh, okay, in this presentation, I'll go over very shortly on PocketQubes, and I explain the AMAJ project and the progress, and then I will prepare the overall plan that we have on this project for the future. So, as you have heard a lot this day, and you know much better than me, PocketQubes are very close to CubeSats in the space industry, but they are now in a much much more affordable case, and also they are not only a good platform to use for education in environments like university, but they are a very good option to be used for starting business in your space. So based on that, we started a collaborative project called AMAJ, a miniature project to administrate joint innovation. This project is out of a collaboration with InnovaSpace and Fazl.ir with uh, three main goals. The first is to test in orbit the very first step of forming a constellation with intersatellite link. The second is to try and test IT mission supporting from space based on LoRa communication, as many of PocketQubes are doing it. And the third is to bring a new approach for making space more accessible, mainly for space emerging countries like Iran. So based on these aims, we started a sketch for the AMAJ. AMAJ is made up of three main satellites. The first is Mother, one new CubeSat, which is going to deploy two other satellites, two PocketQubes called Boy and Girl, in order to form a constellation for IT mission in orbit. So after deployment of these two PocketQubes out of the mother CubeSat, there will be both IoT missions and intersatellite link between these satellites. The PocketQubes are only to receive the uh, signals on LoRa communication based on the LoRa modules that are going to be used, the same as the one is in PoSat 1, and they are going to save them and transmit them regularly in uh, ISL band to the mother CubeSat. So the whole data will be transmitted to the ground using the CubeSat mother. So this platform could be used for training our new and next generation fellows in the team. And also we are going to use it as a platform for innovation management, or also make it as an opportunity to help our fellows for entrepreneurship and sharing market between two countries in collaboration. As you can see, this is the overall design of the CubeSat model. Uh, the CubeSat model is going to be in 1U extended size based on NanoRacks deployer. So we are going to use the extended cylinder, which will be inside the spring of the deployer. And after deployment of the CubeSat will start deployment of two PocketQubes. To make it more tangible, you can see the overall mission simulation. As you can see, after the CubeSat is commissioned and we can control it safely, the deployment of two PocketQubes starts. So the three satellites will start operation in one orbit that will increase the amount of supportable ground stations on Earth for IoT mission. So it is predicted that the distance between the three satellites would not exceed more than uh, 5 kilometers during the mission life that we have considered for the satellites. The project was announced in June 19, and it is not so much late after that. We started to accept proposal on the subsystems of the CubeSat and also PocketQubes. Then we are going to build engineering models and develop the flight models after that. And it is anticipated to cover these models in a period of about 6 to 7 months. So this fast-paced project is needed to be controlled very carefully. To go over the design of the PocketQubes are in 1P configuration, and based on the system design, the ISL is going to be on the base seat and close to the patch antenna, which is going to be uh, placed on the outer surface of the base sheet of the PocketQube. After that, the power board is close to the ISL, the most power consumer part, and obviously will be after that on the next layer or board close to the LoRa. LoRa will be on the top, and it will be close to the antenna that we are going to deploy in orbit after the release. So the structure will be in the form that you can see in the 3D print model here. And we are anticipating that we will have a one-sided communication from LoRa ground station components and two-sided communication between the CubeSat and the PocketQubes in S-band for ISL and delivering the data from PocketQubes. To go forward, there is a single bus for electrical power supply and also intra-board communications. The electrical power supply is based at 3.3 volt main bus, and we have considered a small lithium polymer battery for it, and also the communication between boards are based on I2C. So we have some kind of processing units in each board to handle the other communications. The LoRa is based on PhosaSats, the inspiring PocketQube that we all know about it, and we have some changes in the software in order to receive up to 255 signals from other LoRa transmitters and handle them through one line. And after that, we are going to transfer the data saved on onboard memory to the CubeSat to be transferred to the ground station and then servers by ISL based on XP protocols and using COTS. For the CubeSat design, I should say that we have separated the CubeSat into three main sections, and Two of them are for CubeSat platform. The former is two bigger box in 84, 110 by 21 millimeters, which hosts the communication module and EPS. Communication module integrates the ISL and IoT payload. As you may know that the CubeSat itself owns the LoRa communication module too. And also the EPS uh, is made up of lithium-ion batteries and also uh, integrates the PDU and VCR and BDR units. There are two smaller boxes to host OVC and also the main payload of the CubeSat. We are going to test the main payload of this project uh, based on LoRa communication to increase the number of the uh, units which can communicate to the CubeSat, more than 255 that we have already achieved. And also the third part of the CubeSat will be PocketQube deployer, which is very close to the PocketQube deployer design that our Orbital has presented with some changes in the, as you can see, with some changes in the edges to conform to the cylinder that NanoRex lets us. Okay. Uh, in the shape, you can see that the bigger box are in gold, excuse me, black, and the smaller box are in gold. So the next step was to go for ground station. We have developed two types of ground station in hardware. The first is the one that can be connected to the PCs, so the use of them would be very easy. The same as some kind of ground station that have been presented in previous presentations. We are using some kind of typical antennas used by TV and UHF or something like that, with some changes in the impedance of the receiver. And with this kind of antenna, we can receive different signals in UHF. And based on that, we may use the same VHF antenna that were used by TV or radio stations in RF for CubeSat communications. Also, we have developed another kind of ground station which can be used by PocketQubes or CubeSats. This kind of ground station is uh, typically in handset hardware form, and the handset not only has itself small LCD which can show you some raw data that you have received and can be controlled with some low functional keys based on the thing that you can change it through the mission, uh, but also can be connected through a OTG cable to the smartphone. So the smartphone has an application that we have developed now on Android. So the Android application can be connected to the ground station hardware, so you can control the satellite or follow it on orbit, or see the graphs for any parameter that you have selected to be monitored during the flight of the satellite. Also, you can provide this handset as a tool to be used for IT services. So this can be used as a very simple interface to be attached to the sensors, which we are going to share the data to the satellite. Another part of the ground station is data server that is going to handle the data that we have received from the CubeSat or any other satellite in the future versions and generation of the Constellation, and will provide us a UI to generate some services for our users. Uh, to provide an update, we had a live show presenting the AMAJ satellite, and you can see that our fellows were working in their homes because of COVID-19, we are working remotely. Still, we are working remotely, and we have some sessions, online sessions with our fellows in Iran and also our fellows in Argentina who are in charge of deployer and also a PocketQube. And to go for future plan, I should say that we are not going to just make some PocketQubes or uh, implement some design into the products. We are going to provide some solutions in order to get to business and to some businesses. So we have considered to uh, organize a competition on picosatellites, mainly PocketQubes in Iran, or in order to engage the whole students and who are interested in small satellites, especially on PocketQubes, in order to make the ecosystem. And to do this, we have some support for them on education, also networking and marketing. And there are also some kind of funding and investment in some cases that we find them profitable in future. Uh, to go for our plan, we are working on platform mindset. We are going to provide some platforms that could be used for different kinds of missions that we are going to develop. Also, may other use our platform, like the one that other fellows are developing. Also, a project called PQOB is going to be done. We are going to work on PocketQube on a board to summarize the platform on a board. And also we are developing our technology management system based on IT-based solutions that we have used through the COVID times, and we are going to make it as a service for others. Also, in a business side, we are going to provide some solutions for on-orbit testing and demonstration for anyone who is going to test its components in orbit, and also some services for newcomers. That it was the thing that we lacked, and we lack now. We wanted to test our ground facilities using some satellites in orbit, but we couldn't find any. And also the other thing is to guide the next generation member of our team to provide their businesses on subsystem for sale. You can see a very early image of our ground station software on PC, that there are different parts that we can collaborate with different fellows in this workshop, and also uh, others who you may know that we can collaborate with. And we are start, and we are open and excited to contact with anybody in this workshop and on future opportunities to collaborate on the PocketQube projects, basically on a space or on the Earth. Thank you for the time, and you can contact us using these emails, or you can follow us on Twitter or on Instagram at baza.ir. Thank you.